generate this data, the next question is, what do you do with this data? And processing this data also is an important aspect. And then what are the technologies that will be used to process this data? What are the framework? What are the standards? And then we know once we process this data, we get business intelligence, we get consumer insight, we take very good decisions, but these are tons of data. So how do we process it, and how do we process it efficiently? Now, I just focus on two known technologies in the world. That's the Hadoop and Spark, Apache Spark. Though there are so many other framework or technologies you can use to process big data, but the two most popular ones are the Hadoop and the Spark. And the Hadoop uses the distributed file system whereby it breaks big data into smaller chunks and then they are processed individually, right? So, and it has its use cases. And one of the use cases is the ability to process large data faster. And organizations, let me say the gaming industry, uses the Hadoop framework to process data about gaming online. For example, I don't know if some of us play Call of Duty here. They use Hadoop. Hadoop to check when people pause, where people are having difficulties moving to the next level, and then they go back and process this information so that they can make changes to the game so as to improve, customer experience. So these have real life usage. Spark on its own. Okay, so one of the drawback about Hadoop is that it does parallel processing, or it does batch processing, and it's not real time, right? So even for maybe the military, if they have information archived somewhere, Hadoop is a framework that you use to go and process those tons of information that has been archived. But sometimes you might want use cases where you process this information real time or near real time, and that's where Spark comes in, the Apache Spark. It does in-memory processing, and also it catches some of this data that makes, it's actually 100 times faster than Hadoop. So, but the question is, for me, sometimes it's confusing because if you go down into all this technology, there's so many other technologies. Apache Spark, there's Cassandra, there are a lot. So it'd be nice to have standardization in terms of the technologies or the frameworks that are being used to process this data. So this is the differences between Hadoop and Spark. Both of them are open source, but the cost for Hadoop, they say, is low, but Apache is quite expensive. But they all have use cases, and there is use cases where you could integrate both technologies together as well. Now, this case study is in San Francisco, and I had to use this just to tell us why we need to bring this to our market. Maybe if I had a strong use case to use in Nigeria, I would have put it here. So which still shows that we are still low in the adoption, and we need to make it very easy for people to adopt the big data analytics. So what does this map do? It's a simple map, just help people navigate around thousands of parks in the city of San Francisco. It gives you views of where all the public restrooms are, all the gardens, depending on your lat long, depending on your position, where you are. It takes your lat long. Based on your lat long, it makes recommendations to you and tells you exactly where the closest park, depending on your choice. So we've talked about cloud computing and also big data, but one major concern for people with these emerging technologies is actually security and privacy. Because once you start processing data, you're processing people's data, people's privacy. So people give you all their information, their credit card details, their home address, their name, their date of birth, the things that they like, you know. So you have all this information in your possession. What do you do with it? So data governance is key. There's no way we talk about big data without looking at the governance. Governance is very important. So how we use this data, the integrity of the data, the security of this data, how we house it to ensure that we prevent it from any calamity. Once we start collecting people's information, we're responsible for it. Whatever happens to that data, we are responsible for it. So we need strong framework, we need strong governance to help protect people's data. Now, in terms of the policies, different organizations have their own data policies. They have business rules, business policies, but there's no way you collect data without thinking about the regulatory compliance. You have to be compliant with the regulators. If you collect data and you're not ready to be compliant, then don't collect people's data. I think last year, I think Google was fined about $200 million in US based on the COPPA Act. And that led to a whole lot of changes in YouTube in terms of how they process information for people below the age of 13, right? So data regulation, it's very, very important if people have to adopt this technology. Now, I have this, so this is an example of some of the data regulations that we know, the EU GDPR and the Nigerian Data Protection Law that was just recently enacted, I think last year. Now, the challenges with some of this regulation is the practicality. I can tell you one major concern that users in EU have with the GDPR. Now, the GDPR says that when a breach occurs, you need to report it within 72 hours, or you face massive fine. But if you look at cybersecurity breach report and the analysis that was done, that it takes an average of 145 to 146 days to detect a breach from when it happens. So it means that with that regulation in place, it becomes difficult for people to comply if it takes them longer time to detect a breach. And the reason is not far-fetched. These are tons of data. So the technologies to process the data to detect breach and all of these are part of the challenges with big data. Now, this is like a guidance in terms of governance, the flow for managing big data, how we define it, how we discover what is big data, how we measure and monitor, and then how we apply big data. So the challenges for discussions for us is big data regulation. There's a whole lot of issues around data management. Data management in terms of frameworks, in terms of the standard, how should data be accessed, how should it be utilized, and how should it be governed? The governance around it, which is what we just talked about. And the reason is because big data comes in different shapes, comes in different sizes. The classification sometimes is an issue, even storage, it's a big problem. And then it's very complex, and because of its complexity, to ensure data quality is also a big issue. Now, we have confusing, I call it confusing variety of technologies for managing big data. I talked about Spark, Hadoop, Cassandra. There's still Apache Storm, Apache Hive, MapReduce. So it would be good if it's simplified because right now you need a lot of capacity to decide what big data technology you want to use. And provider lock-in, like I mentioned earlier, how easy it is for you to migrate your data. If I decide not to patronize AWS anymore, it should be easy for me to move my data. But is it that easy today? I'll tell you the answer is no, it's not. Even from AWS, moving from Azure to AWS, any of them, it's not easy to fully migrate your data. So it means if you take your journey to the cloud to a single provider, it means you might be locked into that provider for a very, very long time. Okay, I think this is the end of the presentation. Thank you very much.
Thank you very much, Shaya. Please let's put our hands together for him once more. He spoke very quickly about the drivers for cloud computing, the benefits of cloud computing, the various cloud platforms that we have and we can optimize on. And he spoke particularly about the cloud market in Nigeria and the revenue performance. He also looked at big data regulation and the practicability in real case scenarios. So thank you very much, Chaya, for that robust engagement. The questions will be reserved to the end of the entire session. So very quickly, in the interest of time, we'll move on to our next speaker, who is another prolific personality. She is the current electronic certification director with the Regulatory Authority of Ports and Electronic Communication in Algeria. She has been responsible for several contributions and presentation on cloud computing and the standardization of this technology. And she has worked with several tech companies in the Silicon Valley over the last 10 years. She's currently the vice chair of the ITUT SG13 Regional Group for Africa, and she's none other than Sumia Benba-Towie. Please let's put our hands together for her. She will be presenting remotely. Sumia, can you hear me?
Ladies and gentlemen, good morning. It's my honor.
Sumaya.
Ladies and gentlemen, good morning.
Good morning.
It's my honor and pleasure to be here with you by remote to talk about cloud computing standards, where we are now regarding the standardization of these technologies. But let's start with the definition of cloud computing. What is cloud computing? It's the paradigm for enabling network access to a scalable and elastic pool of shareable physical or virtual resources with the self-service, provisioning and administration on demand. This definition took more than 90 hours of works from experts from ITU and ISO. And it was the first step regarding the standardization of this technology. The basic goal of cloud computing standardization is to make applications more scalable, interoperable, and secure in the cloud. This involves cloud computing interoperability and integration standard. This refers to interoperability between different clouds and integrated interface standards. And it was and still be a big challenge regarding specification of these technologies. 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 Let's talk about the standardization work on cloud computing. The cloud computing involves a wide range of technical and business elements. The targets of cloud computing standardizations are diverse, and many standards organizations are studying cloud computing focusing on their respective areas of expertise. The standards development organizations typically have a process they follow for developing standards. As an example, includes proposal, preparatory, committee, inquiry, approval, and publication. For cloud computing, we can classify the study area into framework development, terminology definition, use case, and requirement identifications, the cloud configuration management, and the inter-cloud federations. ITU did and still done several works on cloud computing standardizations, including creation of the focus group and working party dedicated to this technology, collaborating with the other SDUs, publishing reports and organizing workshops. Focus group on cloud computing were established further the TSAC agreement at Geneva meeting on 2010 with the objective to collect and document informations and concepts that will be helpful for developing recommendations to support cloud computing services from the ICT perspective. The focus group concluded in December 2011 with publication of technical report. This part include different aspects of cloud computing, for example, the definition, the requirement relative to architectures, the security of cloud computing, and also the benefits from cloud computing benefits from telecommunication and ICT perspective. The second focus group were on aviation application of cloud computing for flight data monitoring, and it was established by TSAC agreement in 2014 to identify the requirements for telecommunication standards for an aviation cloud for real-time monitoring of flight data. The focus group concluded their works in February 2016 with the publication of technical report in 4 parts, including the existing and emerging technology of cloud computing and data analytics, the use case and the requirements, the avionics and aviation communication systems, and the cave landing recommendation for next steps and future works. Also, Study Group 13 was designed by TSAC agreement in January 2012 as lead study group on cloud computing. Study Group 13 is the group in charge of future networks with the focus on IMT 2020, cloud computing and trusted network infrastructures. He is the lead study group on future networks such as IMT 2020 networks, also the lead group on mobility management, on cloud computing and on trusted network infrastructures. The study group 13, SG13, working party dedicated on cloud computing and with 3 different questions regarding this technology related to requirements, ecosystem and terminology, architectures and inter-cloud and management. The current SG13 questions related to cloud computing are the question 17, requirements, ecosystem, and general capabilities for cloud computing and data. The question 18, functional architecture for cloud computing and big data, and question 19, the end-to-end cloud computing management, cloud security, and big data governance. The work items under the study of question 70s are cloud computing and big data definitions, overview, ecosystem, and use cases, cloud computing and big data requirements and capabilities, requirements for interoperability, data portability, and exchange information in cloud computing and big data, relationship between cloud computing and big data. The cloud recommendation under study of question 17 are many, and all of them are from the Y series. You can find cloud computing functional requirements for blockchain as services and cloud computing requirements for containers, cloud computing functional requirements of cloud services partner for multi-cloud, and cloud computing functional requirements for machine learning as a service. Concerning the question 18, the functional architecture for cloud computing and big data, the work items are cloud computing functional architectures supporting cloud services categories, for example, NAS and IaaS and PaaS. Cloud computing functional architectures of entire cloud. The cloud computing infrastructures, including cloud networking aspects. The big data functional architectures, including big data exchange, functional architectures, and cloud computing based big data architecture. And the recommendation under study of question 18 for this study period is cloud computing functional architecture for cloud services brokerage. Concerning the question 19, which is question related to end-to-end cloud computing management, cloud security, and big data governance, we have the work items here, and there are many. The cloud services management in cooperation with study group 2, as well as cloud infrastructures and resource management. The scope includes multi-cloud management, end-to-end management, scenarios for cloud services and cloud infrastructures. The big data governance, including data management, data preservation, as well as lifecycle management of big data. Study in cooperation with study group 17 of cloud-specific identity access and security mechanisms that enable effortless trusted access to cloud resources in multi-provider scenarios. To the extent that such cloud-specific scenarios do exist. Lot of work. The recommendation under study of question 19 are many. All of them are from series Y and can find the cloud computing requirements for cloud services development and operation management, the cloud computing requirements of edge cloud management, and cloud computing framework and requirements on container management in intercloud. The global management framework of distributed cloud, the cloud computing framework of risk management, the cloud computing data model, framework for NAS or virtualized network function, cloud computing end-to-end fault and performance management, framework of virtual network services in We have also question 5, which is question working on applying networks on future and innovation this question are to focus on recommendations, technical papers, and supplement, which study the needs of the ecosystem as the whole of developing country telecom networks in terms of applying of different technology like cloud computing. As you saw, there are many recommendations under study on cloud computing, but there are also many recommendations that already be done on this technology. You have in Y series many recommendations related to cloud computing. For example, the cloud computing framework and high-level requirements, and also the cloud computing infrastructure requirements, the second editions. You have also the functional requirement of YAS and an overview of end-to-end cloud computing management. There are also recommendations on cloud computing in X series, which is related to data networks, open system, communication, and security, where you can find the recommendation X1601, which is security framework for cloud computing, and it's very important part of the cloud data now, and security requirement for IaaS and operational security for cloud. You find also recommendation in Q series, which is framework and overview of cloud computing and interoperability testing. The standardization is one of the fundamental key to develop the new technology. Without standards, several problems happen, especially concerning the interoperability, the security aspect, and the SG13 as lead group on cloud computing provide serious effort in collaboration with government regulators, other SDUs, providers, in order to develop the cloud computing standard. SG13 worked very closely in Africa region in order to bridge standardization gaps and enable developing countries to reap the benefit of the technology revolution. So don't hesitate to join us on SG13 works on cloud computing and other technologies. Thank you for your attention.
Okay, thank you very much. We can put our hands together again, even though that was a recording. Yes, it was a recording. I was actually surprised myself. Regardless, we'll still take questions, right? And if you have your questions, we'll take them and we'll email them to the speaker, and the responses will get back to us before the course of the day. So, does anyone have a question from the recording? Any question? Okay, so we'll move on very quickly to Dr. Rui, who gave a presentation, the last two presentations. She's online, and she wants to make some clarification and also respond to the question that you raised quite earlier. So let's listen out. Dr. Rui, can you hear us?
Yes, can you hear me?
Loud and clear.
Yes, thank you very much. Thank you, Mr. Alakija, for giving me the floor again to provide a response to the question asked by the representative from Ericsson. First, I thank the representative from Ericsson for his interesting question that I received on the chat window on the remote access tool. In fact, many organizations in the developing countries, especially who are operating in the telecommunication and banking sectors, are not satisfied with their traditional business intelligence and data warehouses technologies applications, and architecture. So, this lack of satisfaction with the existing solutions, mainly in terms of data volumes, velocity of change, and the ability to handle specific analysis, could encourage organizations to consider migration to big data. It should be noted that motivation differs from an organization to another depending on the needed use cases and applications. Some organizations may not need big data because they don't need sophisticated applications and analysis, and they don't have important volumes of data to treat. I hope that this responded to your questions, and I'm open to any further question on this subject or on the presentation. And you have my email address. Thank you very much.
Thank you very much. Thank you very much, Dr. Rim. Okay, so with this, we've come to the end of this segment, and I'd like to call on Engineer Wakil to continue the program.
Thank you, Ife, and also all the presenters, both physical and remote. We are very much behind schedule, as you can see. We've not taken the tea break. Now it's well afternoon. It's eating into the lunch time. So we will quickly take 10 minutes tea break that is waiting for us. I hope the tea is not cold already. So quickly, let's have a 10 minutes tea break, and then we come and continue. Thank you very much.